Hello everyone, welcome to TubeU channel. I'm Harry. Recently, I have watched a lot of videos about how to use DC motor. Most of them use the DC555 motor, which the power supply is above 12 volt. It makes the motor powerful but a little bit dangerous. I want to make some mini tools using less power and more safety. It will be mostly used in motor fabrication. I choose the Mabuchi motor FA130RA, which usually used in plastic motor.
Let's go.
The power supply is 1.5 volt to 3.0 volt. We can use 1 or 2 alkali battery for the power supply. The speed at no load is 8600 RPM. I make a mini drill using this motor. Finally, I got this. It's cool, isn't it? Stick around. I will show you how to make it. When I use tools, the first thing always be the safety. The second is the preciseness. And the others are quite a lot, such as convenient, price, lifetime, and so on. The motor is small, but we still need to fix it firmly. I use 4 2mm screws. It should be okay, I think. Then the challenge is coming about the shaft coupling. The Mabuchi DC motor uses 2mm shaft, but usually mini tool shaft is 2.3mm. It will take more than 2 weeks if I buy it from Amazon Japan. I think it is caused by COVID 2019 influence, since the products usually made in China and it will take much longer time to deliver. Okay, I have a 3D printer now. I can make it myself. Let's do it. The simplest way, just change 2mm to 2.3mm using a straight shaft. I design print and test. It's not stable. Even the drift is small, such as 0.2mm. The high speed enhances the effect and makes it unstable. Then I decided not to use a rough screw and use a screw tap. Try it again. It is still unstable. If I fix the motor, then the head of the drill will vibrate. I figured out that may be caused by 3D printer processing program. If I fix one side and let another side a little bit flexible, the situation may become better. I changed the top side to a shaft coupling type. First, try 3 separate types. Still no change. Then, change to 4 separate types. Also no change. I found out that the thread directly attached to separate is not good. It may break the balance between each separate part. I changed the head to flat type like this. I changed some parameters such as the slit size, the height, the length of the screw, etc. Finally, I got this. It's really good. Now the most difficult part has been solved. I must choose a flat place to fix the motor. Of course, not use the simple flat test table. One idea comes to my mind. How about using a pistol gun, like a revolver gun? The motor can be settled in the revolver part. Make a room for 2 AA alkali battery in hand part. Okay, let's do it. I searched the internet to find something interesting. There are quite a lot. Finally, I choose this as my motor. I will use Fusion 360 to make it for my mini DC motor drill. First, make a chamber like this. Then put the AA battery box in the hand part. Since I use 2 AA battery for the power supply, I add a switch to give the drill having normal and turbo mode. The circuit is like this. Add a trigger to turn the drill on or off. Add a barrier to protect the head of the drill. Print all parts. Make a little bit of modification. Assemble that. Let's see what this mini tool can do. On, off, it works. Normal. Turbo mode also works correctly. I can stop the motor by bare hand. This means this is quite safe. But take care, don't hurt yourself. My hand is well trained and have a thick skin. It can drain a hole in a soda can easily. Others like cutting, grinding, also no problem. It is enough for me now, since I only want to make a mini tool. And if we change the motor from FA 130RA to Power Dash motor 15,317, which the size is completely same, the speed from 8,600 to 23,600 RPM, almost 3 times faster. The normal load from 0.39 mN to 2.0 mN, almost 5 times powerful. Let's see what will happen. It is more easy to drill a hole in soda can. Also, it drill a hole in wood board very easy. Cutting is more efficient. Everything becomes easy, but it may a little bit dangerous than the normal one. Take care of yourself. That's all for today. I put the STL file in the link below, in case you are interested in printing yourself. Hope you will have a nice day. Don't forget to subscribe to the channel. Also, click on the small bell, so you will not miss the update. PewPew channel is waiting for you.